My name is Ofer Lior. I am a business development manager in Intel in the data center software solution team. And I'm here today to share with you a live demo of a real production Intel DCM instance as it is installed in a data center in some of our customers' environment. You will be able to see down the road that some areas of this demo are grayed out, and this is because not all the information in this live production instance can be shared externally. So let me first start by explaining what is Intel DCM, and then we can deep dive into the capabilities of the product with a live demo. So Intel DCM is a software solution developed by Intel for the past almost 8 years now. What it does is that it uses the telemetries that are built into IT devices such as servers, storage, network devices, smart PDUs. So this capability uses the built-in real-time telemetries that are in the devices that the customer purchase, and it uses these telemetries in order to help a data center operation manager to more efficiently manage the data center. Intel DCM connects to every device in the environment through the out-of-band solution of the device, meaning it is agentless. And then in real time, it collects information for the power consumption, the thermal status, and the health of the device. And then the software UI aggregate this information to a level that the customer will be able to consume this data in order to make sure he's managing his facility with the highest efficiency possible. Let's deep dive into this specific environment that I'm sharing with you right now. So this is the main console of Intel DCM, and you can see that this specific production instance is monitoring 7 data centers with 308 racks and almost 7,000 devices. And every single point of data that you will see here today, keep in mind that this is a real-time point of data. What we're actually doing is we're actually converting every device to be a sensor within Intel DCM. So every server is now a sensor for us, and we have almost 7,000 sensors in the data centers that we can read real time and pull the information from. And I want to start by drilling down to the most granular data point that we're collecting, and then we will go upstream with the data center hierarchy to explain what we can do with the data. So I'm going to drill down in the data center hierarchy in order to get to the most granular point of data. So this is the building where the data center is located. This is the room in the building. This is the row. I now picked a rack, and now I'm going to pick a specific device. So this is one server, okay? And you can see that with this server, the real-time power consumption of this device is 108 watts, and the real-time temperature that this device is sensing in the front panel is actually 19 degrees. We're also pulling the information from the device regarding its asset tag and the model of the device. And this is the most granular point of data that we're collecting with Intel DCM. Now, for every point of data we have, we can trend this data. So now we're looking at a weekly worth of data collected by this specific device. And you can see that here down at the bottom, we have a weekly trend of the power consumption of the device. Here at the top, we have a weekly trend of the temperature the device is sensing in the front panel. Intel DCM is actually configured now to collect the data every couple of minutes from the servers. But basically, the server itself is actually monitoring this data every millisecond. So every data point Intel DCM has is actually built from a large amount of data collected from the server. And this is why we're actually presenting here 3 points for every measured point that we have in the environment, or 3 values. The first value is the highest power consumption that this server measured within these couple of minutes, the average power consumption, and the lowest. And this way you can get a full picture of the data that the server is collecting every millisecond. So this is the trending analysis for a single point of data. And then we can write policies. So Intel DCM is not only a monitoring tool, it is also a control tool. So it can tell the server how much power it is allowed to draw from the infrastructure. We saw that this server is actually pulling 108 watts. maybe I can tell this server to use less power. Maybe I can limit it to 80 watts or 70 watts, and therefore I can reduce the amount of power that this server is drawing from my grid. Okay, so I will not be able to show you this capability because, again, this is a live production environment and probably this server is actually doing something right now. But here is where you write the policies for the rack. You can create thresholds for every point of data that we're collecting, so for every server. With this threshold, Intel DCM will be able to shoot out an alert if the power goes above a certain value or the temperature goes above or below a certain value. So that was the most granular point of data that we're collecting. Now let's try and go upstream in the hierarchy and understand how we aggregate this data to something useful. Now, I'm standing on a specific rack, okay? And this rack has 60 servers installed in it. You can see here the rack elevation. So this rack is actually populated with 4 blade chassis. We have another data point that is added here, and this is the space. So we're using 40 out of the 42 U's that this rack can populate. And we're aggregating the power consumption for these 60 devices. So the real-time power consumption for this rack is 14.4 kilowatts out of the 22 kilowatts that this rack can support. So now we're comparing capacity versus utilization for the power consumption. So the single server that is indicating to us the highest temperature is seeing 25 degrees in the front panel. And now every activity that we could do to a single server, we can do to any level of the hierarchy. So now we're looking at a weekly worth of data for this rack. So this is the power trend for this specific rack, and this is the weekly temperature trend for this rack. And I can write policies for this rack. Okay, so I can say, hey, this rack, please don't take more than 15 kilowatts, for example. And then I will have, we call it a guardrail, but it's actually an insurance policy. So Intel DCM will make sure that this rack power consumption will never breach the power consumption that the infrastructures of this rack can support. And this is where the power capping technology here in the policies becomes useful. Now, I can even go upstream to the full data center level. And now we see some interesting data. So first of all, this specific data center that I'm standing on is a data center that is equipped with 170 racks, with 4,500 devices. And the real-time power consumption for this data center is almost 900 kilowatts, so 894 kilowatts. And we are using about 2/3 of the power capacity of the room. So the full power capacity of the room is 1.6 megawatt, and we're using about 900 kilowatts of that. So the server that is sensing the highest temperature out of all devices that we have is seeing 34 degrees in the front panel, and this is a very high number. And we are using about half of the space of this data center. Now, if we look at the trend, we might be able to see something interesting. So this is a weekly trend of the power consumption of this data center. And here, this big valley is actually the weekend where the data center is located. This peak is the first day of the week, and this is the night. Second day of the week, and this is the night. Third day of the week, this is the night, and so on. So you can see when this data center is operated in prime time, the power consumption actually goes up, and then in the nights it goes down when the utilization drops. We can even look at a monthly trend, and here we get an interesting picture of these big mountains, if you might say, are the prime time in the middle of the week, and these valleys are actually the weekends. So you can see the power consumption of this data center is actually fluctuating quite a lot, between 760 kilowatts to, let's take the pick here, 900 kilowatts. So that's a difference of 140 kilowatts from the low utilization times in this data center to the highest times of utilization in this facility. That was the data, and the data that we're collecting and how we're aggregating this data. But I think what's more important is what we can do with the data that we're collecting. So now I want to show you some of the capabilities of data analysis that Intel DCM has. So first of all, we can create a layout of the data center, and this is a schematic layout of the data center. Every rack here is represented by a square, and now I can start planting this data on the layout. So for example, I can create a real-time thermal map for the average inlet temperature in every rack. So keep in mind, every rack actually has multiple devices in it. So this real-time thermal map is created from the servers inside the rack, and we're actually presenting the average temperature for every rack. So this looks like a very, very healthy data center, right? Because everything is green, maybe bluish. We have just a little bit of yellow over here, but this actually hides the full story. So now let's take a look at the highest inlet temperature in every rack. So now the real-time thermal map will indicate to me the single device that is sensing the highest temperature out of all the devices in every rack. And then immediately you can see that in this area of the data center and in this area of the data center, we have some hotspots. And this is a real issue in a real data center. None of this data is simulated. This is a real production environment, and this is a real hotspot issue in a data center. Okay? I can also present a color-coded map for the power capacity versus utilization in every rack. So for example, this rack is utilized with 80% of the power capacity that it can support, and this rack is populated with less than 50% out of the power capacity that it can support. I can do the same for space capacity. So for example, this rack is utilized with 95% out of the space it has, and let's take a blue one or a green one, and this rack is actually populated with 47% of the space capacity that it can support. If I go back to the layout, here at the side you can see the electrical panels or the electrical boards that are supporting every row. And these are modeled in Intel DCM. So if I click this and say, go to the cabinet PDU, immediately you can see the list of racks that are fed from this row PDU. And then if I go to the layout, I can actually create a simulation and see what happens if this electrical panel fails. So let's click this, and this is only a simulation. Immediately you can see that if this row power distribution unit is failing, these are the racks that will lose one of their power feeds. And if I find its twin, let's simulate this. So if I lose these two, all the racks that are colored now or blinking between gray and red will actually lose their power. Okay? And this actually reflects the redundancies that we have in this specific data center. And now let's remove the simulation. Another capability you can put on the layout is, let's go to a specific row, is you can take a look at a frontal thermal map of the data center. And in this frontal map, you can see the temperature in every server as it is installed in the rack. Okay, so this is a thermal map from a front view of the racks in a specific row in this data center. So that was the layout. Now, additional analytics capabilities are available here in the Energy Optimization tab. And I want to start with the cooling analysis capability. So if in the layout we were able to see hotspots and identify issues in specific areas of the data center, the Energy Optimization cooling analysis allows you to actually zoom out and take a look at the data center as a full facility to understand how efficient this data center is running. And I will explain what we're seeing. So, first of all, in this data center we have 4,050 devices that has temperature sensors that we can read. So actually we have 4,000 temperature sensors in this room. And here we have a histogram that represents how many devices are sensing every temperature. So for example, I have 883 devices that are sensing 21 degrees Celsius in the front panel. And I have only 197 devices that are sensing 24 degrees in the front panel. And I have just a very small amount, maybe 51 devices that are sensing 27 degrees in the front panel. I will explain what we see. So reading this, I can say that this is a very, very efficient data center because most of the readings are between 19 degrees here to 24 degrees. We have a small amount of devices that are overcooled, so meaning we're pumping too much cold air into them and they're seeing a low temperature. And we have a lower amount of servers that are undercooled, and these are the hotspots actually. just to compare, let's take a look at a different data center that we have in the environment. And here, this data center is much smaller, 1,300 devices. But immediately you can see that this data center is overcooled because all of the readings are between 16 degrees to 22. This means that we're actually overcooling this facility, and what the data center manager of this facility should probably do is that he should increase the set point of this facility to move this whole histogram to the right-hand side in order to save money on cooling. And not only it gives you the indication that this is what you should do, but Intel DCM will give you the confidence to do that without impacting the environment, because every server is now a sensor. So if you're increasing the set point in, let's say, 1 degree, waiting a few days, if something happens, you will know on the device level that some of the devices may not like the new set point that you put and are showing a higher temperature. So it will tell you that this is what needs to be done, and it will give you the confidence to do the change without risking the environment, because you have very, very granular data with regards to the temperature of the room. Another capability here in the energy optimization is the server power characteristics. And this is a tool that can help data center managers with planning the power consumption of future landings. So we here analyze every model of server that we have in the environment to show what is the expected power consumption in peak power for this model of device. So let's pick one. So for example, this device, we have 2,000 devices like that in our environment. And you can see this device never took less than 45 watts when it was in idle, and never took more than 521 watts when it was peak powering. And if I click this, I will get the full statistic of the population of these devices in peak power. And I will explain. So for this specific model of servers in the environment, we can see the statistics for the peak power, meaning here, this is the percentage of the population, and this is how much power they take from our grid in peak power. So if I draw an imaginary line here, I can say that this specific model of device, and the number here is probably 380 watts. So I can say that this specific model of device will never take more than 380 watts in peak power, because the majority of the population of the devices of this model in my environment never take more than 380 watts, because they're all here to the left-hand side. We have just a very, very small amount of devices that we've seen since we've started measuring that they're taking more than 380 watts. And now the data center manager can actually use this information in order to better plan future landing. And he doesn't need to rely on the spec of the device with regards to the power consumption, because the spec of the device has a value called the nameplate of the device. Nameplate of the device is presenting to the user what is the expected power consumption when the device is fully utilized with all the hardware inside it. So sometimes you don't buy all the disks, and sometimes you don't install all the memory DIMMs, and this will give you a much more deep analysis on what's the power consumption for every model of device you have in the environment. Let's see some more capabilities. So devices and racks. And here Intel DCM can actually help you with placing servers in the environment. So let's say I want to land some servers in this specific data center, and I want to land some servers from model A, and maybe model A, and maybe this model is a 2U device, and the expected power consumption for this device, because I measured it in the server power characteristics, is 380 watts, and I want to land 9 devices like that. But I also have a model B, and this device is actually a 1U device, and the power consumption is 280 watts, and I want to land 7 servers like that. So I can ask Intel DCM to find me the best location to land these devices. and I can choose between two placement strategies. The first one is round robin, and I will click suggest. And what round robin will do, it will evenly distribute these devices across the data center. So probably it will choose 16 racks and land one device in every rack. And this is exactly what happened, right? So we're seeing here that Intel DCM chose 16 racks and placed one server in every rack. And this means that these 16 racks can support both the power consumption of this one device that is going to be installed there and the space that it needs. Okay, so that's the round robin strategy. And you can use this strategy, for example, you have a thermal issue in the room and you want to evenly distribute the heat load of this specific server's landing. Okay, but I can also be greedy and say, hey, Intel DCM, please stack them up as much as you can in a single or maybe two racks so I can use the footprint of the data center as efficient as I can. So let's click suggest, and Intel DCM will find, and here you can see it found one rack, so rack 23 in row 2. Intel DCM will find one rack that can support all 16 devices, both from a power perspective and from a space perspective. Okay. Now let's move to some more analytics capabilities. And here I'm going back to the dashboard. And here in the health analysis widget, you can see that Intel DCM is actually collecting data for the health of the devices that it is connected to. It is collecting information regarding the health of the memory DIMMs, the hard drives or the disks, the fans, the processor, and the power supply. And again, this is a live production environment, and every time I go in, I see a different value. But basically, all we have in this very, very large environment are 3 servers with a memory DIMM failure. And Intel DCM will immediately show you that these 3 specific devices has a memory DIMM failure. And I am sure somewhere in this organization IT, there is a ticket to actually fix this issue with the memory DIMMs. So that's the server component health monitoring capability. And the last capability I want to show you today is the cooling anomaly analysis. And this is where Intel DCM crosses the line from being a monitoring and control tool to being also a predictive tool. And I will explain. For the first 2 weeks Intel DCM is installed, our algorithm will actually learn the thermal profile of every single device in the environment, the thermal profile of every rack, every row, every area in the data center, and every room. And then, after 2 weeks, not only it continues to learn, but it starts to analyze the data, looking for anomalies on the cooling of the infrastructure. And I will give an example. So if I say there is one server that is overheating in the data center, then probably this is not a big deal. Because one server, this is one device, it does not indicate anything about the environment as a facility. And probably it's an issue with the device that needs to be fixed. But if I see an increase in temperature in 50 devices, even if this increase in temperature is only between 20 degrees to 22, but on 50 devices, and all this happened in 5 minutes, and all of these 50 devices are actually located in a specific area in the data center, maybe a side-by-side rack or maybe a single rack, then of course this is a very, very good indication a thermal issue is developing in our environment. And Intel DCM will shoot out an alert in SNMP or in an email or inside the console to make sure that the data center manager knows that something is developing in the room. And this is where we can actually prevent thermal issues before they put an impact on our environment. This capability actually increases the SLA for the data center. I think probably that's it for today. There are many more capabilities with Intel DCM. Thank you very much for listening today. And if you have questions or need more information, you're welcome to visit our website and find all the information regarding this product from Intel. You can find us online in our Intel DCM website.